All right. Anything else that you guys want to add? Okay, so it's like a virtual word wall. Instead of just listing down the letters, we try to show how they relate to each other. Okay, so now we're gonna move on. In the next part of our agenda today, we're gonna do a Desmos activity, and hopefully you still remember, the meanings of all these terms. Um, okay, so here we go. Our our Desmos activity today is called Linear Function Fitness Club. So you find that in the same folder, right here, where it says 3.2 decimals. Oh, that's a typo error. That should have been 3.2. Okay, so you sign in with Google. I have to sign in with my teacher account. Okay, let me know if you found it. Nope, that's not where you're at. Okay, hang on. I can't open the chat right now. Give me one sec. It should be this one. I click on it. There are no aligned materials with this course. It says something went wrong. Okay, we'll try to. I'll set it again in the chat. Copy. And then try if you can log in straight from here. Yeah. I see three of you are in it already. I know sometimes the connection of another website with Schoology is tricky. So sometimes it works, sometimes it doesn't, and I don't know why. So we'll try it again right here. So go ahead and click on that one. If you guys can open directly through the chat, that will be better. That one worked for me. Okay, great. Yeah, I'm happy to hear that. Okay, so let me share my screen again. You're in. Nice. Okay, so the first one is your typical know and wonder. What do you see and what related facts do you know? What else do you notice? So that's the first question. The second one is what do you wonder about, or what questions might you have about the picture? All right. Nice. And it doesn't have to be like a paragraph. Could be just a phrase, a word or two. Yeah. Okay. Nice. That's why, you know, when I do this in physical school, I don't want my kids to write a lot, but I want to hear them talk about it. So that's one of the things why I always keep using, I try to keep using that breakout room. But it will be nice on Monday when you can actually be ready to, yeah, like be physically and like camera wise present. Okay. Because this chapter, there will be instances of oral exams. I will be giving, what do you call this? You will be given a word problem and you have to answer it like live. Okay, you're not gonna write. You're gonna answer it live, and you're gonna be graded as you um, say your answers aloud. Okay, so now let's move on to slide number two. 19 of you did slide number one already. We're 25 total. Let me know what did it work with the other with the other students? Okay, so on the second slide, we guys are going to identify variables. Oops, wrong spelling. Sorry about that. Okay, so identify variables. The function y is equal to 7x plus 35 represents the monthly cost y in dollars of a group of X members joining the fitness club. So, what are independent and dependent variables? You can think of this as cause effect relationship, just like in science. Like what must happen first before it it you know brings about effect in the other variable. So here we're talking about two variables, y and x, where y is the cost and x is the number of members. So, you know, what do you think is the variable that causes changes in the other? Okay. So independent variable is x. So what is x about? So what is x in the story? Okay. So x equals what? So it's pretty much like when you're defining variables when you're problem solving. So you're going to say something like x is equal to, or let x be equal to what, and then y is equal to what, right? So those are your dependent and independent variables. Nice. So x is the number of members. Very good. And then y being the or the dependent variable. Okay. So the cost is the number of members that will, bring about effects in the amount you're going to pay, right? So the more members joining, the higher amount you guys will pay. So this is like the type of conversation that I would like to hear, you know, hopefully next time, instead of just me just reading your answers, we will be like talking about them like in a round table. So um, we'll do that on Monday. Please be ready to share aloud on Monday. Okay. All right. That's great. Very good. Okay. So now we're trying to provide more structure to our functions. In this slide, you guys are going to create a table of values. Create a table of values. So what if your group has enough money for up to 6 members to join the fitness club? So create a table of values to show the amount paid for 0 to 6 members. 0 to 6 members. Okay, so you're going to fill up that table. Mhm. Starting with 0. Can you add another row or not? Maybe I counted. Yeah, I meant to put like enough rows, but okay. If you only have enough rows for 6, that's okay. I meant to put like enough for all the entries, but maybe I counted wrong. Oh, there's 8 rows. I put 8 rows, so you can start from 0 all the way to 6, right? Okay. So start from 0 all the way to 6. And there's a reason why I'm forcing you to start from 0. Okay. So please do not miss 0. You have to start with 0. Okay. And don't forget to label your columns. Sorry, Brian, I volunteered your table. Um, do not forget to label your input and output with the variables that you identified in the previous slide, right? So that's the reason why you have to identify your variable. What variable you're going to put in the first column. Good morning, Giselle. And what variable you're going to put in the second column. Let me send you the link in the chat, honey. Give me 1 second. There you go. So we are working on decimals. All right. Okay, so now you guys start filling up the second column. So if I may volunteer Elisa's table. So I like how you labeled your columns, Alyssa, members and then cost. Now, maybe in parentheses, if you guys are looking at the screen, maybe in parentheses you could put X like that, and then the cost would be Y. There you go. But that's important because when you guys make some ordered pairs, you have to consider the order in which the numbers are written. Okay, thanks, Alyssa. I volunteered your table. So Alyssa said if there's zero members or x is equal to zero, the payment will be 35. Okay. Yeah, so try to remember the function that was given at the beginning. It was y is equal to 7x plus 35, right? Y is equal to 7x plus 35. Okay. Okay, most tables are still empty. You gotta fill it up like entirely. Well, except the last maybe row. Yeah. So stop at 6. Okay. Hi, Jaylene. I borrowed your slides. Okay, so Jaylene, 35 for 0 also. And then 42, 49, and so on. Okay. Now, as you guys are filling up the table, try to think of the pattern. Try to find a pattern. Okay. Because it's not just about filling in the table. On the next slide, you guys will be analyzing. So that's why, I'm really, really fond of um, putting you in groups and talking about it because I love, you know, hearing conversations around how do those mathematical concepts, relate to some questions that you will see in the next few slides. So the first one is identify the possible domain and range of the function. Hmm. Now I want to see how you guys would answer that before I help you up. How or identify the possible domain. Remember, domain is the set of possible input, right? Okay. I want to see first how you will answer that before I offer some help. Identify the possible domain and range of the function. Okay, if you're listing some numbers, make sure you start with the curly braces. So find those curly braces on your keyboard. It's next to the letter P. Excuse me. All right. Very nice. Okay, so I see most of you writing down, the values of X on the table as your domain. Good. Okay. And the range are the costs you listed down for the second column, right? Okay, so in general, the domain actually, aside from, writing them down like you did, okay, so it could be a set of non-negative integers, right? I mean, conceptually, it doesn't have to stop at 6, right? But in the story, I said you only have enough money for 6. Okay, so the domain will just be from 0 to 6. But if I took out that restriction, then the domain would actually be the set of non-negative integers. Okay, because the number of people joining the gym could be, more than 6. All right, so it's really important that you base your answer in the context of the story. Nice. Okay. Okay. So if you guys look at your screens, the domain is a list of numbers that can be found in the first column, in the X column, which are the possible number of members joining the fitness club. Okay. Now, oh, that's an interesting one. Look, you said the range is 35 to 77. Now, does that include 36? Does that include 74? You know what I mean? So, I don't think I will accept like giving me like 35 through 77 because they are actual data points. Hmm. Which will lead us to a very interesting question later on. Like when you graph them, are you going to connect them? Because if you say the range is 35 through 77, then that means, oh, you can include the decimals. But in the context of that story, are there any decimals? Right? Okay. So you might want to think about that again and rewrite your answer. Okay. Next, slide 5. Plot the ordered pairs from the table of values. Plot the ordered pairs from the table of values. How do you go to my original? Okay. It doesn't have to be like a perfect graph. I mean, um, I tried to like show, enough spaces for you to plot maybe 6 pairs. Yeah. Hi, Chris. Are you labeling your axes with the dots or you're plotting the points on the axes? So remember how you guys plot points. When you plot points, the first ordered pair, when I say point, you're not going to mark 0, 1, 2, 3 with a dot on the x-axis, meaning 0 and 35 go together, right? Okay, so that means when x is 0, you go y up to 35. And then when x is 1, y is 42. So you're not going to put one dot on 1 and one dot on 42. Like each ordered pair is just one dot. Yeah? Okay, so remember the parts of the Cartesian plane? One goes to the right and then 42 goes 42 up. So just try to kind of, place that in the middle of a box. Okay. Yeah, because I saw a lot of like dots on the X and dots on the Y. Okay, so if you're trying to be creative, this one is not the time for that. Because dots on X and Y would mean you plotted the 1 separately, you plotted the 42 separately, and that's entirely wrong. That's entirely wrong. Okay, so I must see numbers for your X and Y axis, but I don't want to see the dots right there. If you're putting dots on the X and the Y axis, your graph will be marked wrong. Okay. I think I have to like say that explicitly. Hmm. How do we zoom out on the table? Oh, you can't. I'm sorry because it's fixed. Yeah. Okay. So sorry about that. Yeah, it's not like the uh-huh. It's not like the standalone decimals. I had to like create my own window and then that's the one you're using right now. Hmm. Hi Dwight. Um Dwight, can we take off the points on the X and Y axis, honey? If I may write on your graph, if this is 1, 2, 3, 4, 5, and so on, you think of a, try to think of a convenient scale for your y-axis. Let's say you skip from 0 to what's your first number. You can start from 35 if you want to. Okay, if you want to go by fives or by tens, however you want it, it's up to you. If you can't show all the dots, that's okay. Uh-huh. So let's say when x is 0, y is 35. So that means when x is in the middle, you go up. There you go. That's the first point, right? Okay, and then when x is 1, what is its partner? So if you go by 5s, 42 is somewhere here. Or if you want to go by 7s for the scale of your y-axis, you can also do that. Uh-huh. So there should be no dots on the x and on the y-axis. Okay, so let me erase this one. There should be no, like, dot many dots, okay, on the x and on the y-axis. Um, okay. Brian, your graph caught my attention. Sorry, I'm showing it on the screen again. Um, that's interesting. You show the trend line, but should we connect them in the story? Think about it. So that means can I have x is equal to 1.5 right here because it's in the middle? Can I have this? If this is a solution, then that means 1.5 comma, what is this? Maybe like 45 or something, whatever that amount of dollars there. Does that make sense in the story? Remember, your domain is the number of members. And do decimals make sense in this scenario? Okay, don't get me wrong. Like, we graph linear functions, we do, but there are instances when you know we cannot connect the points because the solutions in between don't make sense. Okay, so we're not graphing like a random y is equal to 2x. Okay, so if we're graphing like a random function, then go ahead and connect them all you want. But that's why we discuss about discrete and continuous graph, right? So, oh, nice one. Look, you even marked the ordered pairs. Thank you for doing that. All right. Okay, so I assume this is 35. Okay, nice. Let me look at another one. Christopher has the dots. Okay, also showing like a straight path. So you let the dots like speak for the pattern. You don't have to. Don't force them to be connected if they cannot be connected in the story. Nice one. Okay. Um, all right, Sophia, that's okay. It doesn't have to be a perfect line. At least you see the pattern that it increases as it goes to the right. Correct? Okay. So you're. Uh huh. Did I include a space where you can explain or no? Where it says describe the trend shown by the points. Maybe I forgot to put the text box for that one. That's okay if there's none. Maybe I forgot. And if I edit now, you have to like start from the very beginning. Okay, so next, let's go to the last one. So for the last one, how does the graph show the changes in the values recorded in the table? How does the graph show the changes in the values recorded in the table? Mhm. So remember, you have to relate what you saw on the table and what you graphed. Mhm. So if I may borrow Sophia's table, you have to explain how the changes in y in your table of values, so you have to figure out by how much that went up and by how much your x values went up, right? And there's a term for that. I'm not sure if you remember from middle school. Nope, I don't want to call it slope yet. We're not there yet. I know. Okay, so when you guys are trying to compare, okay, so what is the slope really? So slope is just a rate of change. Yeah? Okay, so rate of change. So by how much is your cost changing with respect to the number of members? By how much is your cost or amount paid changing with respect to the number of members? And how does that show? Okay. By 7. Good. So you wanna say something like, for every additional member, the cost increases by what? By how much? Okay? So I'm somehow kind of, providing you a script already, because when you guys take SBAC, they're looking for buzzwords, and I know you can explain it in your own words, but it's going to be a computer that will grade your work. And if the computer does not recognize the buzzwords that it's programmed to give points to, then, you're not going to get the point. Okay. All right. So for every additional member, the cost increases by what? So that shows on the table. And now you're going to relate that. Thanks, Sophia. I um, use your example. And now that sentence, you're going to relate it to the graph that you created. If I may borrow Giselle's. Okay. So how does, for every additional member, the cost increases by the length show on the graph? How are you going to explain that on the graph? So if you guys look at Giselle's example, like if I draw this triangle here, do you remember doing this in middle school? Right? Okay. Oops, sorry. So what is the change in the independent variable here? So we know like one horizontal unit here is 1, right? And then what is the vertical change here? So look at the keywords I'm using. I'm talking about horizontal change, right? Versus a vertical change. Okay? And I know for sure you can relate this to something you did in middle school and why I put the vertical change on top. So the vertical change here that's from 35. Oh, I lost my pen. Where is it now? Oh, it's acting up. Okay. So like the vertical change here is, I would assume that's from 35 to 42, so that's 7, right? So in the graph, um, so there's 7 units in the vertical change, while there's 1 horizontal unit, 1 unit for the horizontal change, right? Okay, so I don't know if you remember that in middle school. Remember your rise over run? That's the same thing as what we're doing now. So the ratio between the vertical and the horizontal changes is actually 7 over 1. Okay, or 7, because 7 divided by 1 is 7. And regardless of what points you use, that's going to be constant, right? So 7 and then 1. Okay, so you say the ratio between the vertical and horizontal changes is what? Okay, so that's how you guys can relate what's happening in the table and what's happening on the graph. Okay, so in other words, you're trying to interpret your graph based on the context of the problem. Okay, and that's something that, you know, you guys, I know for sure, can explain very well, and just writing it on the screen won't catch that moment. So that's why I really, really encourage us to engage in conversations next time. Do we write this somewhere? Um, you have to remember this is scripts, because whatever problem I give you, those are the buzzwords I'm going to look for. But in slide, let me go back to that slide. In slide number 6, yes, you have to like write them. That's for number 1 alone, right? How does the graph show the changes in the values recorded in the table? That's for number 1 alone. Now for number 2, in which parts of the graph can you see the constants used in the function? And remember, your function is y is equal to 7x plus 35. You screenshot, that's okay, honey. I'm not very particular as how you do your notes, as long as you get them, as long as you have them. Mm-hmm. Yeah. Okay. Yeah, so you can screenshot and then just save it for later. Yeah. Okay, so going back, like how do the constants show in the graph? If we can go back to the graph right here, I'm gonna borrow Nick's. Okay, so where do the numbers or constant 7 and 35 show? I think I kind of discussed the 7 earlier already, right? So 7 is when you get the ratio between the vertical and the horizontal um, change, right? But where does the 35 show? Where does the 35 show? And if I may add a point on your graph, Nicholas, because I don't see the 35, honey. If this is midway, so maybe 35 is somewhere here, right? Okay. So just by looking at the graph, I can tell that, oops, you're missing something. Because when I'm checking your graph, I'm checking for whether you're showing this number and this number. I'm pretty sure you remember what they are from middle school. What are they? What is this number called, and what is that number called? Well, in here, in Nicholas' graph, so that's where the graph crossed your y-axis. Coefficient and constant. Yes, so this is the coefficient, but in the context of the story and in the function, that coefficient is actually your slope. There you go. This is where you can call it the slope now, because this is in slope intercept form. There you go. Slope intercept form. I know, like I flipped today's lesson. I did not front load you with the vocabulary, but instead, we elicited the vocabulary from the actual problem. Okay, so that's the coefficient, that's the slope. This is your y-intercept. Okay, y-intercept. There you go. So in the context of the story, your y-intercept is 0.35. What could that be in real life? What could that be in real life? Like when you go to the gym and say, hey, I want to start working out. What do they tell you? They discuss some paperwork and stuff like that. So what could you be paying, with that $35? Um, a yearly plan. That's great. So you're paying something up front, right? Maybe the sign up fee, maybe the maintenance fee. We don't know what it is. It's called differently, but the y-intercept is actually, the amount of, payment you give them upfront for maintenance, for membership, for sign up, etc. However you want to call it. Okay. Now, the vertical and horizontal change, which is 7, or the slope, or what is that? You saw that on the table. The y column increases by 7. You also saw that on the graph. The ratio of vertical to horizontal change is 7 over 1. So what is that 7 in the context of the story? What does it mean? What does it represent? If you're talking about it to a friend who's not studying math, what would you call that? You're not going to say that's the slope. So in the story, what does the slope represent? What does the slope represent? Anybody? So you pay an upfront fee of $35, and then, right, when X is 1, but what is 1? 1 is the number of members, right? So for every member, how much are you paying? For every additional member, how much are you paying? Come on, in the chat. Um, there you go. Yes. So the increase is $7. So that means the $7 is the fee per person. It's the fee per additional person. You get what I mean? Okay, so you see where so you see where I'm leading you to. I'm not so much about can you graph this function. I want you to be able to talk about it and like interpret its meaning. Okay? Yeah, so 35 has to have a meaning, 7 has to have a meaning. And that, my friends, is what I will be expecting from you. So I'm not just going to say, okay, y is equal to 2x minus 2, and then graph it. Nope. That's just the beginning. Okay, so you saw what the possible questions I'm going to ask you about the graphs that we will be doing. Okay, you're going to interpret, interpret, interpret. All right, awesome. Okay, so make sure you guys finish whatever you need to finish in this decimals. I'll try to record that as soon as possible. Oh, by the way, if you look at your Schoology, there, instead of like waiting till when the grades are due to put in the zeros, I marked them with zeros already. Why? Because I saw the pattern kind of like when I put the zeros, and that's when you do them. And it threw me off last grading period because when I sent you that text reminder, um like it took maybe like 4 or 5 hours after two for you to say, Miss, I did this, I did that. And I had to like work so late to kind of, reflect reflect those changes in your updated grades in MySys. So what I'm trying to do now is I'm putting the zeros already in advance so you would see that, oh my God, it brought my grade down. Okay? Yeah, but it doesn't mean that you cannot do them anymore. You can do them, but I'm just buying myself more time, you know, because yeah, because I saw that trend in the past two grading periods. All right, I'm gonna leave this one open because I'm gonna record the number of slides that you finish. Nice. Okay. All right. So now where are we? Going back to Schoology. Oh no, sorry. Can you go to deltamath.com, please? Deltamath.com. You do have a homework that's due on Monday, okay? But in addition to that, we will be doing something else like right now, like live. Oh my God, what's happening to my hand? Okay. I think I'm using the computer too much. My hand is getting numb. Good morning. You're too late for your Zoom, honey. Okay. So you will see something in Delta Math called Zoom 3.1. So I called that Zoom 3.1 because we're gonna do it like right now. You're going to Mexico? Oh, take me with you. Okay. I might join some meetings here or there. It's gonna be hard. I know. I had a homeroom student who went there, and yeah, like she had to be brought down to like a town, you know, so she could like use the internet. same thing in my own country. There's not internet everywhere. Okay, so try your best, honey. Yes. Okay, so where are we? Let's do this. Let's do this work over here. Okay. Oh. Uh. Okay. How can I show this live? Can you skate? Can somebody like share um his or her screen? Okay, hang on. Tools, because I cannot log in as a student. Can I? Let me see. Sample student page. How about that? Let's try. Nope. Here's one. Okay. And we're looking at um okay. Oh yeah. Okay. So now I'm logging as a student. But what's the first thing? Hang on. Okay, do you guys see this example on your it's not on your page? Oh, okay. Some people are going to attend. Oh, yeah, 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 yeah. Okay, so if you need to log out, that's fine. This is on Deltamat, so you can also do it later on. It doesn't appear on your page. That's interesting. It should be like a regular individual work or something. What about the others? What shows on your screen, guys? I have that one, but not the other one that says Zoom. Oh, sorry, sorry, sorry. Okay. So does it show this? Yes, I want to be able to like discuss the same problem with you, but I don't know if you see this. Anyway, you see it or not, you will see it later. I don't know, like I don't know the particular order it's going to show on your account. But anyway, so fill in the blanks below in order to justify whether or not the mapping shown represents a function. So, for example, here, what do you think is being shown? Like for every x number, there's only one y or b number, right? So in this case, the mapping diagram represents a function since for each number, it doesn't give the same problem. Um, yes, for the regular assignment, it doesn't give the same problem, but for this one, I clicked on assign this problem. So can you double check on that and let me know if it doesn't? Yeah, so it could be like in a different order though. Yeah. Anyway, I'm showing you an example over here, so hopefully this will also help. So for each number in set A, which is the input, right? There, okay, let me move that. So there is only one mapping to set B, which is the output. To set B, which is the output. So you see, these words might make your answers wrong if you guys don't line them up correctly. So set A is the input, and set B, you see that they're kind of tricking you. This is also set B, but it has the input with it. So you have to see the pairing up. Okay, so I'm gonna click on yes, and there you're gonna get it right. So that's how you guys are going to do those kinds of problems. Okay, now I want to show like a different kind of problem, which is the visual domain and range. So here we go. All right, so if you guys have this graph right here, you're going to write an inequality, okay, to show the answer. So let's say, for example, this graph starts at what? This starts at -11. So you put -11. It's a closed circle, so you have to use less than or equal to. And then the variable is x. And then you're going to trace the curve and figure out where it ends. It ends at x is equal to 1. So you're going to put less than or equal to 1. So that's how you guys are going to, answer questions like this. Oh, I answered the domain. I'm sorry. That's the domain. I didn't see the question over here. It says find the range. So for the range, you're going to look at the possible y values. So the range starts at here. It's -6. So the range is -6 and then stop where? The graph stop at y is equal to 3. There you go. So when you're looking at the range, hang on, honey. Mommy's teaching. So you're going to look at the minimum y and the maximum y. The answer I typed in earlier was for the domain. So if it's the domain, you look at the minimum x and the maximum x. So let's submit our answer. Click on yes. And what did I do? Okay. I made a mistake? Your answer is not correct. Try to find your mistake. You have 1 attempt remaining. -6 to positive. Oh, sorry. My variable is x. It should have been y. My bad. Okay. There you go. Okay. So I did the same mistake twice. Like I look at the x value, right? When I entered the inequality because I thought I was getting the domain. Okay, so for the range, you have to use the variable y. Okay? Use the variable y for the range. All right. So that's how you guys answer such types of questions. And let me see what else. Determine. Hang on, honey. Mommy's teaching. Okay, determine. Oh, it's right there. I put it there. Okay, so determine which set of ordered pairs does not represent a function. So in other words, you have to find that set that has a repeating x input. Okay, that repeats x, right? Because that one will not represent a function. Okay, so can you find that? So is -9? No, the x is not repeating. The x is not repeating. Yeah, the x is repeating there. They use 9 twice. You see that? Okay. And then this one is not repeating. So submit answer. And here we go. All right. Okay. So that's how you guys will answer those questions. Okay. You guys have any questions for me? I hope I was able to model each kind of question right there. I think I finished it, right? Is there anything I skipped? Oh, determine if a graph is a function. Um, so you're gonna do like the vertical line test. So if it crosses your graph only once, then this will be a function. Um, yes. Okay. I see that one. That's a nice simulation. Okay. Alrighty. So I do hope I was able to help you with that.